I'm doing vaughn. What's up, YouTube? I should be sleeping, but instead I'm doing math. I'm going to write a Java program for you. Basically for people who I tutor to understand how two-dimensional arrays work. So what we're going to do is we're going to apply the magic square concept to a program. This is the magic square concept. You can watch YouTube videos on how the magic square works, or you can just watch this particular video because we're going to build a dynamic magic square. So in order to build that, we need to go ahead and write a Java program. We're going to write our Java program. So we declare a class. We're going to declare a main method. So we're going to go to our original position and go down. If you don't understand what the args are, I would suggest you experiment with that. Right one. Okay. Now every magic square has its own. So first we're going to do the 3 by 3 magic square going 1 through 9. The magic constant is 15. We're going to make sure our magic square is working. So we're going to do javac javac magic square.java, and then we're going to run our program after this compiles. For example, 8 plus 1 is 9, 9 plus 6 is 15, 8 plus 3 is 11. So here you can see the dude's magic square. Public class. So we've just misspelled this wrong. S-Q-U-A-R-E. So now recompile that. Alright. So as you can see, dude's magic square, where that's compiling, we'll explain it. You start out at any given point and you move according to a predictive algorithm, which is you move up 1 and you move over. So if you move up here, your square kind of folds. So if you move all the way at the top here, if you start up at the top and you move up 1, you go back to the bottom. If you're here on the right and you move over 1, you go to the left. So basically, since you start out here, you move up 1, you come here, you go to the right 1, and you plot this point. Then from here, you go up 1, you go to the right 1, which folds you back over. You plot this point. You go up 1, you go over 1. Since there's already a point plotted there, you go back to your original and you go down 1 and you plot that point. Up 1, over 1, plot that point. Up 1, over 1, plot that point. Up 1, up 1, over 1. Already something there. So you come back, plot that point. Go up 1, over 1, plot that point. Go up 1, over 1, plot that point. Then you're over, and whenever you're done, you can add up any row and they'll give you a magic constant, which in this case is 15. I think it's always going to be, I don't know how you're gonna calculate this magic constant, but we will actually try to devise a way to calculate this magic constant. Program's then compiling. Java magic square. So let's make sure that it's working and we don't get no errors. And it's working, so let's write the inner part of our program. First thing that we're going to need to do is we're going to need to ask a user to tell us what square they want to create. You can create 2 square, 3 square. So whatever square you're going to create, that's what you're going to create a matrix of. You're going to create rows and columns of that size. So let's go ahead and do that. Alright, boom, magically we created a bunch of code. Let's explain it. So we need a 2-dimensional array, and we're going to call that square. We need that to be accessible to our whole program because basically every time we create an object of the magic square class, we want it to be whatever size that we ask it to be. So we can create an object, and then once we can create that object, we can say, hey, I want you to create a square, and that square should be whatever size square that you decide that it should be. So there's our square object for the class. So magic squares work, and there's our system.out print line. In order for this to work in an object-oriented program, in this particular model, since we're going to run a main method from here, which is just pretty much for testing, the way you should think about this is eventually you could take this out of there and not have a main method in this class, and then import this class into another program and do the same thing, create a magic square and the main method of that other guy. So P, that's our magic square object. So this square for P is going to be create square. So what we do is create square. We create a temporary array. We ask the user for a square vector to create. We declare a scanner. We do java.util.scanner because we don't have an import statement because we're only going to use the scanner once. We use that to get the index, and then whatever index that you input, we create a new square and we return that square to you. So now square, this your program square, is whatever size square you decide to create. To prove that, what we're going to do is we're going to write a method to print out the square. So let's go ahead and do that. So now, bam, you see some more code. The only code that I've added here is I've added these two methods right here, and I've added these two calls right here. So basically, after you create your square, so let's run our program real quick and look at it, and then we'll go ahead and explain it. So enter our square vector. We want to create a 2x2 magic square, and we want to create a 5x5 magic square. So if you look, all I've done is I've added these two different methods. First method that I call is print square with coordinates, which is the first thing that happens right here. I print out this square with the coordinates, so I have the coordinates 0, 0, 0, 1, 1, 0, and 1, 1 for my square with the vector of 2, and my square of a vector of 5, I have 0, 0, 0, 1, 0, 2, all the way up to 4, 4, as you can notice. And then I call print square, which is the same pretty much function. It just doesn't print out the coordinates. All it does is print out this particular value that's located at those coordinates. So you can see my magic square here, and you can see my magic square there. So this particular video that is right here is a 3x3 magic square. So let's look at that. So here's my 3x3 magic square that they've created right there. So now I need to write an algorithm that basically asks a user to pick where you want to start at, and runs our algorithm by starting wherever you want to start at, going up 1 and over 1, taking into account that if we're at the upmost part and we go up 1, we need to fold down to the bottom, and if we're at the rightmost part and we go right 1, we need to fold back to the left. So let's a little bit more code for you, not that much. We just wrote two more methods, and we wrote fill method, and we added in a value. We need a value because basically what we're going to do is we're going to start with the value of 1, and we're going to do our fill method. We're going to go up 1 and over 1 and add the next value. Okay, so our value is going to start off as 1. It needs to be accessible to the whole program. So after we print out our square, we need to do our method to fill everything out. So when we start our method, first thing we're going to do is we're going to say, okay, value is 1. We're going to ask for your starting point. We're going to get your starting point from a camera. We're going to set our y and x values. We're going to get those positions of where we want to be at, what our starting point's going to be at, and then we're going to set our initial value. Then we're going to make a loop. Okay, so let's look what our program does right now. Then we'll go ahead and write the loop. So if we make a 3x3 square, you can see we got our 3x3 square starting with 0, 0, 2, 2. So where do we want to start at? Let's start at 2, 2. We're going to put a 1 in our value. So from here, what we'd want to do is we want to go up 1 and we want to go over 1. So technically we'd want to go at 1, 0 and make this a 2, and then we want to go up 1 over 1 and go to 0, 1 and make this a 3. So let's go ahead and actually write our method that's going to do that. Alright, check it. We've got even more computer code now, and we've changed some of it around, but hopefully you get the point of it, and everything's pretty much done, so we can create any size square matrix we want to. And after this, after the initial creation, we just actually have to go in and do some mathematical checking to make sure everything checks out, and then print them off and study them and do some hypothesis. But the mathematical squares are done. So here's our mathematical square class. In our mathematical square class, we're obviously going to have a two-dimensional array. We need a value, which the value is going to start from 1, and it's going to go to the max value of the array, which you can get by taking the size of your array and cubing it or squaring it. So if you have a 3, if your array size is 3, if your size vector is 3, then your max value is going to be 9, because 3 squared is 9, or 3 times 3 is 9, or whatever. If it's your max vector, if your vector is 9, then 9 squared, or 9 times 9 is 81. Your max value is going to be that. Then you have your current position, where you're at in your actual matrix. You have your y position and your x position. So we print out that magic square is working, even though we spelled it wrong. We create a new magic square object, and then we have our magic square object set what our square is by calling the create square method, which is right here, which is pretty simple. We went over already. We print out the coordinates. We commented out to print out the square, so we can get rid of that. Then we have our fill method, and we commented out this print out the square as well. Okay, so we have our fill method. Let's take a look at our fill method. Here's our fill method right here. Notice that these 3 methods on top of it are just the methods that we already created when we called create square, and we're going to call print square with coordinates, and the other one is just print square. So look at our fill method. Our fill method starts out with a value of 1, prints out for you to ask what your starting coordinates is. It gets your starting coordinates, it sets the value at that starting coordinates, and then it also stores your current coordinates. Well, it sets variables anyways to store your current coordinates, and it creates an index for your loop, and your index is going to be equal to the square of whatever your size vector is minus 1, because the minus 1 is where you set your initial value. So then we loop through it. When we loop through it, we tell you what your current position is, which is your y and your x, and then we set your temp position equal to those. Then we make your move, so we move up 1 with the position y equals minus 1. So if you're at position y is going to be 2 here, if you go up 1, you're going to 1, so you're subtracting 1. If you're here, you subtract 1, you go to -1, and you go to 2. Okay, so we've added in some code to do that. Same way here, if you're right, you go +1, you go to the next. Okay, so if you're at 1, you want to go to the right, you go to 2. You want to go to the right, you go to 3, which this is 0, this is 1, this is 2 for your index. So that's what those do. And then we print where we moved at, and then we fold, which fold basically just means that if we were here and we go up 1, instead of being -1, we need to be at a 2. If we're here and we go right, we move over 1. Instead of being at a 3, we actually need to be at a 0. So that's what our fold method does. We can look at our fold method, and that's exactly what it does if you look at it here. So, and then we check to see that whenever we fold it and we get that new value folded, is there anything in that box? So the first thing we're going to do is we're going to go up 1, and we're going to go over 1, which is going to bring us here. Is there anything in this box? No, there wasn't, because we started at 1, so that's 2. So then we go up 1, over 1, anything in that box? No, there's not. So we set our value, go up 1, over 1. Is there anything in that box? Yes, there is. So instead of setting that value, what we're going to do is we're going to move our temp, we're going to move our position y or position x back to the temp that it used to be, and we're going to add 1, and we're going to move x back to the temp that it used to be and take 1 away. So we come from here, we go there, and is there something in that box? Well, yes, it's not a 0, there's already something in there, there's a 1 in there. So we want to go back to our position y, and we want to add 1, so we want to come down, and we're right here with x. Well, we want to go back to our original x, and that's where we want to put something in. And before we do that, we want to fold, and make sure that whenever